Hey everybody, how's it going? Thanks for joining me. I'm Corey. I go by CoreyJA on the internet. You can find me and my blog at CoreyJA.com, and you can find me as CoreyJA on GitHub, Twitch, and YouTube. Today we are going to be doing some Advent of Code challenges, or an one day of Advent of Code challenges. So Advent of Code are these code challenges that come out one a day from the 1st through the 25th of December. And I am a few days behind. So we finished 11 last time we did one of these. So we are going to do day 12 today. And with that, let's jump right into it. Day 12, Hot Springs. You finally reach the hot springs. You can see steam rising from secluded areas attached to the primary ornate building. As you turn to enter, the researcher stops you. Wait, I thought you were looking for the hot springs, weren't you? You indicated that this definitely looks like hot springs to you. Oh, sorry, common mistake. This is actually the onsen. The hot springs are next door. You look in the direction the researcher is pointing and suddenly notice a massive metal helixes towering overhead. This way. It only takes you a few more steps to reach the main gate of the massive fenced-off area containing the springs. You go through the gate and into a small administrative building. Hello, what brings you to the hot springs today? Sorry, they're not very hot right now. We're having a lava shortage at the moment. You ask about the missing machine parts for Desert Island. Oh, Olive Gear Island is currently offline. Nothing is being manufactured at the moment, not until we get more lava to heat our forges. And our springs. The springs aren't very springy unless they're hot. Say, could you go up and see why the lava stopped flowing? The springs are too cold for normal operation, but we should be able to find one springy enough to launch you up there. There's just one problem. Many of the springs have fallen into disrepair, so they're not actually sure which springs would even be safe to use. Worse yet, their condition records of which springs are damaged. Your puzzle input was also damaged. You'll need help to repair the damaged records. In the giant field just outside, the springs are arranged into rows. For each row, the condition records the condition records show every spring and whether it is operational or damaged. This is a part of the condition records that is itself damaged for some springs. It is simply unknown whether the spring is operational or damaged. However, the engineer that produced the condition records also duplicated some of this information in a different format. After the list of springs for a given row, the size of each contiguous group of damaged springs is listed in the order those groups appear in the row. This list always accounts for every damaged spring, and each number is the entire size of its contiguous group. That is, groups are always separated by at least one operational spring. That would be 4, never 2, 2. Yep, okay. So condition records with no unknown spring conditions might look like this. So there's no question marks, and these show like 1, 1, and then 3 in a row. 1, 1, 3 in a row. However, the condition records are partially damaged. Some of the springs conditions are partially unknown. For example, we have some that we don't know. So for this one, we don't know these first 3, but we do know it goes 1, 1, 3. So the only way for it to go 1, 1, 3 is if it was here and here with a blank one in the middle. And dot means, what does dot mean in this case? Dot is operational and damaged is the hash. Okay, cool. Equipped with this information, it is your job to figure out how many different arrangements of operational and broken springs fit the given criteria in each row. In the first line, there is exactly one separate group. 1, 1, 3. There's exactly one way separate groups of 1, 1, and 3 broken springs in that order can appear in that row. Yeah, there's only one solution like we just looked at. The first 3 unknown springs must be broken, operational, then broken, making the whole row broken, operational, broken, operational, broken, broken, broken. The second line, though, is more interesting, and we didn't look at this one. It's repeated here. It could be a total of 4 different arrangements. The last question mark must always be broken to satisfy that the final contiguous group of 3 broken springs. Okay, yep, so that one must be broken. That makes sense. And each double question mark must hide exactly one of the 2 broken springs. And for either of them, neither one could be both broken springs, or they'd form a group of two. And if that were true, the numbers afterwards would be different. Since each one could be, it could come in the first one or the second one, there are 4 possible arrangements. The last line is actually consistent with 10 different arrangements, because the first number is 3, the first and second number must be dots. I'm not going to read through all of it. However, the remaining run of them must hold. So all of these are valid, and there's 10 of them. In this example, the number of possible arrangements for each row is 1, 4, 1, 1, 4, 10. Adding all of the possible arrangements up, we get 21 total. So that is what we need to do. Okay, so let's see. This is our sample input. So let's copy this and let's get started. Okay, so we want to make a new cargo binary. That's what we've been doing for all of these. And actually, no, it's not that. It is that, but it's cargo new. And then we want to make a binary crate. It's day 12, and it is called Hot Springs. And the name is just going to be Hot Springs. Oops, CD into 12 with autocomplete. There we go. And then we have to add this to our cargo.toml in our workspace. This, because a cargo workspace folds all of our crates together. And this just tells it which ones to treat as crates. And we want to treat 12 as our crate. Oh, I'm already in that. Cargo run. Nice, we get our hello world. Let's drop in our sample.input. Okay, so we are going to, sorry, shirts got all tucked in back there. First thing that we're going to want to do is parse these into rows. We'll get like information about all the characters, and then we'll get the groupings after it. And I think we'll go from there. I think for part 1, we're going to do kind of the naive thing, and just like anytime there's a question mark, we'll see what we'll like try both ways and like keep splitting and test all of them. And then we'll see if we need to improve on that for part 2. Yeah, that sounds reasonable. I think that we probably will have to improve on that for part 2, but I think that'll work for me at the moment. So we're going to want to parse into a struct called row. They were actually just calling these all row. And yeah, we're going to have some cells. I like that. And then we're also going to have some sets. So like broken sets or something. And this is just a vec of like just a count of them, U32. I will make it a U size because it'll be a count of something. And let's make that cell. It's going to be an enum of either empty, broken. No, it's working, broken, or unknown. Cool. Struct row is never constructed. Yeah, that's okay. And then we're gonna want to, let's do this in the opposite order now. Now let's do let sample input, let sample part 1 answer, debug sample part 1 answer, and now let's make our function part 1. We're hopping around all. Oops, it's just part 1, and I think I did it that way. Yep, input is some string. And we're going to output a U size. Okay. So let input, we're just going to shadow it by parsing it. And we're going to do input.lines. So we're going to go over the lines in our input. And for each one, we're going to do a map. And we're going to do row parse. And that function doesn't exist yet, but that's okay. And we'll collect them into a vec. And we'll call that rows instead. And then let's add a to-do here so that eventually it'll be happy. But we need to implement that parse method first before the compiler will be happy. Parse takes in an input string, and we want to return one of us, a self. Okay. So let's look at our row. Copilot might have got it, but that's okay. The first thing that I'm actually going to do is split on the space so that I can separate the cells from the counts. So let mutable split equals input.split on space. Let cells equal the first thing. Let broken sets equals the second thing. So then cells, yeah, we are going to do basically something like this, except these aren't the characters that we expect. Working is going to be a period. Broken is going to be the hashtag, and unknown is going to be a question mark. And any other character goes to invalid cell. Perfect. And then the broken sets, we're just going to take them and split them on comma. Yep. We're going to parse over them, right? Just to parse them into U64s and collect that to a vec. And then we're just going to build our self out of our cells and our broken set. It wanted to be a character instead of a string. Same up here. Rust Analyzer will do it for us. Cool. So now we can parse our row, except I didn't let the cell parse itself, and I'd rather do that. No, I don't need to do those. The names are pretty self-explanatory. The input here is actually just going to be a character. And it's going to do a self, working, broken, unknown, panic. Perfect. So now instead of this can just be cell parse. Perfect. Nice. And then let's add a derived debug to this, and I need to do that to cell as well, so that I can debug out rows. Do that with a borrow so that I can keep using it later. 3, 2, 1 is the last one, and we got a bunch of things. Okay, awesome. So I think I want to just now, oops, I didn't actually want to debug this. We're going to do no to this. Hopefully that doesn't make it too unhappy. Oh, it did. That's okay. Can I just have my terminal back? Yeah, I didn't actually want to do actual debugging. Okay, so I think what I want to do here is just for each row, I'm going to make a method that does count how many options there are. So let's go ahead and do that. So function count possible. Yeah, count possible. Okay, so it takes in a self and returns a usize. So what I'm thinking is I want to walk down each thing. And we're gonna do this recursion-y. And when we walk down each thing, we're gonna have a counter that says how many possible solutions we know of so far. And if it's a oh wait, no, do I need that counter? No, I don't think so. I don't think that's what we're gonna do. We want to, if we're unknown, we'll make a copy for one where we were one way and one where we're the other way. And when we get all the way out, we will see if we match the set of broken sets and then count how many match. That didn't make a ton of sense, I don't think. But I think I know what I'm doing, and let's go. Okay, so we have the vec of cells and our vec of broken sets. And we want to count possible. So I'm going to make some helper functions for the recursion here. So we have a function that's called count possible. Yeah, take some cells and a broken set. And does it take a current index? Or how do I... No, we'll just make a copy, because we're just gonna make cell copy and clone. We'll just copy and clone these things. I think that's fine. So we'll just make a copy of our cells. And I do need the whole, I was thinking if I could just like pass on just the end of it, but I need to pass on the whole set of cells so that we can count against the broken sets at the end. Because I need to make sure. Okay, let's do this not recursively. I think we can do this not recursively. Let sets equals a vec. Yep. for... Oh man, this is actually not going to be super easy to do without recursing either, is it? Okay, let's go back to thinking about it. I think I do want to do it recursively. I don't know if I love the function I started with, but that's okay. And then actually no, let's just make it over here where we know the self things. And then there's a current index. Oh wait, no, but I don't want to do it on this because I want to make a copy of the cells and I don't want to make a copy of the whole row. Ooh, this one's a little, I'm having a little trouble figuring out what kind of recursion I wanted or how I want to structure this recursion, but that's okay. An array of cell and an array of broken sets, that's fine. That works for me. And then I want like a current index, I think. Oh no, I can just do it one step at a time until there's no ones that are unknown. Yeah. Okay, so if cells dot iter dot any where the cell is unknown. If there is one, so if there's not one though, then this just returns 1. Oh, we can't equal cells. Okay, let's fix that by making this partial equal. I'm a little unsure about the return value too, but that's okay. So now we know there is an unknown somewhere. So maybe I should have just found the index of it. Let unknown index equals position of an unknown. Nope, no. So then oops, didn't want to bring up chat mode there. Let's actually do let some unknown index equals unknown index, else do this. Because if the unknown index was none, that means there was no unknowns, so there's just one possible in that set. Oh, and actually, I guess we should see if we match broken sets. So to do, we know there is an unknown at index. Sure, that works for me. Okay, so, but here though, we don't actually just want to return 1. We want to return 1 if it matches broken sets and 0 otherwise. So now I want to do something like let cell sets equals 2 sets, and then you pass it cells or something. Yep. And then if cell sets they're just equal, return 1, else we return 0. I'd rather that be an if else, I think, rather than an if like that. And actually, can I make these not be this way? There we go. Oh, no, I do need the return here because I just want this whole else chain to return. I didn't realize that I was in this else thing for a second. Okay, so now we need this 2 sets where we're just going to count how many sets there are. So function 2 sets. I don't think that's... Actually, maybe it is what I wanted. You have sets, current set equals 0. If it's working, you add 1 to the set. Yeah, except I don't think I want to count working, right? Because I think I want to count broken. So I think I flipped these. And there has to be a working in between. And we really shouldn't get any unknowns here. Unknown cell when counting sets. Function 2 sets is never used. That's not true. Oh yeah, it is, because count possible is just never used. Okay. Cool. I think that works. We're just gonna keep going, and we'll debug once we have enough of an implementation written to start running it. Okay, so we know there is an unknown cell at index, so now we just need to do both of the sides together. So let working cells equals cells dot clone. Oh yeah, no, we actually can't do a clone, so we need to make it a vec. So cells dot, I don't know if we need to make it a vec, but iter dot collect a vec something. Let broken cells be another one. Working cells at unknown index equals working. Broken cells at unknown index equals broken, and then we do yeah, let working count as that, let broken count as that, and then working count plus broken count. Perfect. Oh yeah, okay, so this we want to do then cloned, so that each of these is owned here and not a reference, and then after that we need to make those not references. Can't mutate that, that's fair. Mutable. Oh, I can just call 2vec. Love it. 2vec. Perfect. We count them, return that. Perfect. Okay, so then I think this is just count possible of self.cells. Yeah, just that. Self.that and self.broken sets. Reference to both of those things. Perfect. And then in our part 1 here, we just do rows dot iter dot map count possible sum, and that's what we return. Awesome. 0. I'm gonna go with 0 is not the right answer, so let's figure out what is going on. 0, just getting a big old 0. That doesn't feel right. And we already did this, but I'm gonna do it again. We can debug out our rows, and yes, there are indeed some things there. Nope, that's fair. My sample input's not the right sample input. It's the one where they were all known. There were no question marks at all. That'll do it. That'll give us a 0 for sure. There we go. Now we don't get a 0. I still didn't get the right answer. I still did get a 0. But now we get unknowns. So, progress. So it seems to me like we're probably getting to the end and always falling into this. So that kind of has to be the case, right? Because if we are getting 0 every time and we have rows, the only way is if every row returns 0, and the only way that every row I think is going to return 0 is if we get into this for everything. So let's at the end here debug our set counts. Actually, do I want to do it here? No, let's do it here so that I can do cell sets and broken sets. Just kind of curious what we're getting out of that. Okay, cell sets is... Oh, and it's going to put zeros in. We don't want to put any zeros in. Oh yeah, and I think I saw something else that's an issue. Okay. So if you find one that's working, you set it to 1. Like you put the current set in. Wait, if you find one that's working, if current set does not equal 0, if current set does not equal 0, we add it, and then we set current set to 0. Yep. And we can set current set to 0 regardless of whether we pushed it. If we find a broken one, we add 1 to current set. Yeah, that's better. 19. That's closer. Isn't the answer 21? 21. Ooh, so close. Okay, so let's print out each row's answer. Let's get rid of the debug that I added in the counts, or of each row. Debug. There it is. Cool. Okay, so let's do that here. We also don't need that. Let's collect this to a vec. Yep, that'll work. Let counts equals that. Debug counts, but the borrow, so that I can do counts dot iter sum. Okay. Run. 0, 4, 0, 1, 4, 10. Okay, so the zeros here are our issue, because there's exactly one way this works. So why are we getting zeros, I wonder? Yeah, okay. And then 4, 1, 4, 10. 4, 1, 4, 10. Yep, okay. I wonder why these ones are getting the wrong answer. I guess that's like what we're gonna debug now, right? But that's interesting. Okay. So we're getting some that say nothing matches, but we know that something matches. So let's actually just look at the first one here. So let first row. Hey Opus, how is it going? We're getting back to some advent of code. We are, you know, a few days behind, but that's okay. Let broken set. No, I don't. That's fine. Let's debug out the first row dot count possible. Yep. I guess I actually don't really know what I wanted to look at there. Just want to look through my logic and see what we're seeing, I think. Oh, no, I want to print. I want to see all the sets that we look at here. So let's debug sets here, and let's make sure that we actually don't do all of these. We can parse all the rows, that's fine. We're only going to count possible of the first row. Perfect. Then this can just be a to-do. Oh, nice. Opus, doing all right. Got a new PC, so things are finally running smoothly again. That's awesome to hear. Glad you are up and running with a new one. That's always fun to have a new PC as well. Okay, so we have no sets at all, a set, two set, 1 and 1. Oh, because we probably don't add a set at the end. So it was in our sets implementation here, where we want to maybe make a new set at the end. Because they're allowed to end at the end. We don't have to actually have a working one to complete a set. Opus says, pushes a lot of heat in gaming, but it also keeps my feet nice and warm since I put it under my desk. Will be pretty nice when it's super cold out. Yeah, that's the benefit of a computer like that in the wintertime, right? It can double as a little space heater. That's awesome, though. Glad it is working out. Okay, so now we can just do rows. Dot into iter. Yep, map, count possible sum. Think we're gonna get 21 this time. Yeah, awesome. Okay, let's pull in my input. My input. Drop that in. Oh, wasn't typing there. Let my input, my part one answer, debug my part one answer. Ooh, okay, so even, oh, I didn't run this in release mode, so I can definitely run this in release mode if I need to. But I usually don't have to for part one. Okay, that took a little while. Let's run it in release mode and see how fast it is. Still took a second, not nearly the 7 seconds, so it's a lot faster. And is it right? Yes, it is at least right. Okay. Day 12, part 1. And it's the naive solution, but that's okay. We will take it. Oh, that just means I need to push. Awesome. Okay. On to part 2. Let's see if we're going to need to switch up our naive solution quite a bit. As you look out at the field of springs, you feel like there are way more springs than the condition records list. When you examine the records, you discover that they were actually folded up this whole time. To unfold the records, on each row, replace the list of spring conditions with 5 copies of itself, separated by a question mark, and replace the list of continuous groups of damaged springs with 5 copies of itself, separated by a comma. So this row would become that row, and the first line in the above example would become that. In the above example, after unfolding, the number of possible arrangements for some rows is much larger. Yeah, okay. After unfolding, adding all of the possible arrangement counts together. After unfolding, adding all of the possible arrangements counts together produces 52,500. Yeah, big number. Unfold your condition request. What is the new sum of possible arrangement counts? Okay, so I think we're going to have to optimize here. I don't think we're going to be able to do this naively. But the first step, I think, is going to be the expanding. So let's do the expanding. Okay, why is it showing me this? Because there's still one after expansion, I guess. Oh, yeah, because it expands to this. And that's still... Oh, no, it expands to this. And apparently there's still only one answer to that. Okay, cool. Let's get started on the expanding. And then we will work on this. Except the expand, I think, is going to be pretty easy. So I think, really, it's going to be part 2. Is going to be, yep, we're going to map to rows and then let expanded rows is rows dot, let's just do iter. I think it's okay. We're going to do for each of these rows, we're just going to call expand and collect that. Expand doesn't exist, so let's go ahead and generate the expand method. Okay, it generates a new set of rows. And replace the list of spring conditions with 5 copies of itself separated by question marks. Okay, so let new cells equal a vec. Oh yeah, okay, I know what I want to do. I want to say new cells, and then we do a self.cells, and we want 5 of these. And we want to join that with a cell of unknown. Slice the trait bound array of vex. Oh yeah. Dot flat. Nope, no, I don't want flatten. Do I just want a vec of the single thing? I felt like I could do this, but I actually am not sure exactly how I want to do it. I could just like loop through times and not add this, but I really thought something with join felt the most elegant. And I probably don't have to make this vec, but that's okay. It felt like it's what I wanted to do. Oh, is that what I needed? The trait bound Vexel borrow that is not satisfied. Dang. Yeah. I guess taking a Vec of Vex to one Vec is a little bit like, because what I want here is a Vec of cell at the end of the day. Okay. So new cells is just a Vec for I in 0 dot dot, and then I think it's 5, right? 5 times? 5 copies of itself, yep. New cells dot push dot append. No, yeah. Append a clone of them, and then if I does not equal to 4, we push a unknown. Cool. And then let a new broken sets, and then we do the same thing, except it's not 5, it's 5 copies of itself with, oh, it is 5 copies of itself. Okay. And this one, do we need to do anything? No, it's just the 5 copies of itself. I think there's an easier way to write that. I think we can just do dot into iter dot flatten dot collect it to a vec self cells and broken sets. Ah, yeah, definitely got to make that mutable. That makes sense. Can't move out of broken sets, which is behind a shared reference. It does not implement copy. Okay. Oh, this has to implement copy for this to work. Oh no, just cloning, it's fine. That's good enough. Okay, cool. Expand is never used. That's fine. Let's go use it. Oh, now they're all expanded. Perfect. Debug expanded rows at 0. Let's just do a to do because I'm like pretty positive that's gonna take way too long. Now let's not run it in release mode because I want it to compile faster. Oh, this is just how long it takes to do the part 1 in debug mode. I forgot about that. Oh, and I'm not calling part 2. Oops. Okay. Let sample part 2 answer, and let's not do my part 1 right now. Let's debug that out. I'm not actually getting that far yet, but that's okay. Okay, so expanded. Oh man, that's a lot of things to read. Unknown, 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 working, broken, broken, broken. Unknown, 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 working, broken, 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 and then 4 of them in a row. Unknown, 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 Yep. Okay, that looks right. And then 113, 113, 113. 113, 113, 113, 113, 113. Okay, perfect. JS or Python broken routine. We are doing this in Rust. Because I like Rust and I've been having a lot of fun with it. So we are doing this in Rust today. I know some JS and Python. I know more JavaScript than I do Python, but we are doing some Rust today. Nice, yeah. Okay, so like this would work, right? I could just do it over expanded rows, but I don't think it'll work with a reasonable amount of time. But I definitely don't want a product there. I would just want to sum of them. So like this would work I mean, it might work fast enough for the samples. So it takes like a second even to do part 1 like that. So I think it's going to take way too long to do the next part. Oh, I'm not sure why I'm in recording mode in my editor. There we go. Yeah, I didn't think this was going to work. So let's quit out. Cool. Okay. So how can we make this faster? So we basically have the exact same problem we had in part 1. It's just now a bigger, we made our problem bigger. So I think one thing that we can do is when we're matching against this list, even if we're not all the way through, but the prefix doesn't match, we can just abort out early. So like, once we don't have a 1 in the first set, we can just not even continue down. So let's make that optimization. I think that'll be really helpful. So that is gonna be when we're counting possible. Let's get this out of our way for this second. So it's gonna be on our recursive count possible here. So when we're going down, right now we only check against the broken sets at the very end, like when there are no more unknowns. But I think I want to check it earlier than that. I think I want to check it like here. And so, yeah, I want to get some cell sets at the very beginning, but I do know that to do that, I'm going to need to change this implementation from panicking if you get an unknown. If we get an unknown now, what do we want to do with our counts? Oh, we just return. Then we stop the loop. This breaks us out of our for loop. And then we just return however many sets we had at the moment. And actually, we don't even want to do this, because if we're in the middle of one, we need to count it as both like maybe and maybe not. We don't want to immediately break out. So I think we actually just forcefully return sets from here. Yep. So now this is like partial to sets. Like it doesn't do the full ones. As soon as it hits an unknown, we're just out of there. But that's fine for this. Okay, so then for all of those cell sets. So like I want like a, I'm not actually sure if I want that for loop. I want to say, is this a prefix match? So like if broken, like let's just do prefix match between cell sets and broken sets. If there's not a prefix match, then we can return 0. And it's going to be a reference to both of those, I have to imagine. Yeah. Where did you put it though? Right there. I wanted to put it right above it. So close though. Okay. So for I comma C in cell sets dot iter dot enumerate. Oh, this returns a Boolean. Actually, no, let's make it return a enum of prefix full match and maybe just those. And so then it's either, it's an option of a prefix match. Option of a prefix match. It might be like a standard library way to do this now that I have gotten this far, but we're not doing that. Okay, so then we want to do if C does not equal the broken sets there, then we go with none. Yeah, yep. If there's any that don't match all the way through cell sets, we return none. If, yep, If they're the same length, then it's a full match, else it's a prefix match. Perfect. So if let prefix match equals doing that, if prefix match is none, I forgot that this is an option actually. We return 0. Yeah, no, I think that's all I wanted to do right now. We just know that if it's not a prefix match, we can just return 0 and say that it's not possible. And I think that'll speed this up quite a bit and hopefully still give, ooh, length is 3, but index is 3. Where is that? Oh yeah, that isn't gonna work. If cell sets dot length is greater than, oh no, length is greater than broken sets length, just return none. They can't be a match if that happens. I think that returned faster. That seems like it. There we go. I think that's the right answer. Right? Okay. Okay. That seems like it might be fast enough to get us an answer here. Let my part 2 answer debug my part 2 answer. I don't want that white space. Run it in release mode. It's definitely going to take a few seconds. It took 3 seconds to do the sample, so I'm thinking maybe about 10 seconds here. But we will see. The sample was a lot faster, so it could be even more than that. We might even need another speed up now that I say it. But that was enough for the sample, and we'll take that. We just cut off a lot of the possibilities so we don't have to test them anymore. I also like the if there's too many sets thing, which is kind of what the prefix match also just did by returning none in that case. So that's good. Okay, let's let that run then for just a second while we figure out what else we might want to optimize next. So we already are saying that if it's not a prefix match, we're just going to throw it away. And then if there are... Oh, and then here's where we could use prefix match. So then let's do let some prefix match equals prefix match, and then this is in the else. Because now prefix match is just the enum here. We don't actually have to do this again. This is either going to be partial. Wait, the types say it could be partial or full. But if there's no unknowns, oh no, then it would be a partial would be return 0. Yep, okay. So if a prefix match equals full, return 1, and we can't do equals on them yet, but that's okay. That one's easy. We want to derive, oops. Sure, I don't really need copy clone, but I'll take them. Yeah, we don't need to do 2 sets again. We already did it. Perfect. Okay, so we look for the prefix match. If there isn't one at all, we just return. We don't, no reason to keep going. It's just, it's too late. Cool. There's got to be more tricks that we can do with like the numbers of them. Because it's not really just about counting them. Like there's a 2 to the power of thing, right? But these aren't all powers of 2. Oh wait, these are all powers of 2, I think. Log base 2 of this number. That wasn't very helpful. Log base 2 calculator. 14, yeah. Those are all base 2s. That feels like a thing. Okay, so how can I take that? Let's look at some of our inputs. So 0, 14, 0, 4. Ooh, that one's not a base 2. Okay, that's good to know. Huh, I'm not sure if that was actually like a coincidence or not, or something that I should be caring about. Okay, yeah, so that still wasn't enough to make it fast enough to not need to care about anything else. Yeah, so I just make a copy where I flip 1 and then do the recursion again. Yeah, that definitely is the easiest implementation. But I feel like I could make this same implementation just a bit faster by like, I don't have to count from the beginning. I could only count from here on out, but because it's with sets, that gets a little harder. Yeah. Yeah, if you had a full match or else 0, yeah. Mm-hmm. Hmm. I'm not thinking of an immediately obvious way to optimize this. I'm not even thinking of an amazing way to just completely redo it and do it differently either. Like, I'm not really thinking of a good way besides just total brute force for this one, which is strange. Is it still running? It is still running. Good. Is it using much memory? Doesn't look like it. No, don't even think it's breaking a sweat. Gotta be something with the powers of 2, though. 411, 411. Oh, but I'm looking at the, yeah, I want to look at this one if I want to see it say 1. Yep. Yeah, so like if it's just all question marks in a row, it does seem like we can do something a little bit easier, but when it's something like this, it gets more tricky. This one feels like brute force is really going to be the best way to count. Because 1316, it's not obvious to me that that is the only way to do it. So to get 6 here, you got to go 2, 3, 4, 5, 6. And then you can have that one, 1. And then that's your 3. That's your 1. Yeah. Uh-huh. But I don't always know if it works that easily. Yeah, I don't know a way to make the computer do that very well besides, again, just brute forcing it like we're doing. So can I make the brute forcing more efficient? Like, okay, so what if we don't do both? Is there a way to only do one or the other? Not really. So will this prefix match? No, this isn't, no, uh, there was something where I returned early, this, 2 sets. So when you're making sets and you're going and you find something, there is an unknown. Right now, we just give you the sets until it. But we could give you something better here. But no, that doesn't really help. And it really does help to simplify the problem just to keep the vector. I can't imagine that would simplify it a lot. What I was thinking was when we're doing the prefix matching, if you hit an unknown thing and we throw away that whole set, that's slightly unfortunate, right? We might be doing more work than we need to. So we could not throw away the whole set and let you know how many we had gotten to, and then we hit an unknown. But that makes this return type really complicated. It's not just a vec anymore. And I don't really think it has a ton of benefit. I think we're just doing a lot of counting. Like there's just a lot of things to work through here. And do I need the whole set of cells? A little bit. I don't think there's a better representation that I can really think of. Yeah, and when we return 0 here, we obviously don't keep recursing. We only keep recursing if we need to. Yeah. Not sure what optimization we can really do here. There's got to be a math kind of trick or something somewhere that we can use. So when we expanded it, it had 5 copies separated by a question mark. But that didn't always help, like, right? This is still, there's only one valid way there. It's not like they always multiplied by 5 or something. 1 4 1 1 4 10. One big number, 1 4. Yeah, so they're not even the same. There was ones that were ones. There was 3 ones here and they don't all match up. 1 1 16. Yep. Yeah. This one's interesting. I'm not thinking of a better thing to do than brute force, but brute force is obviously too slow. But maybe it's just an algorithmic variation on the idea. I'm not sure what that means. So like if we're going through a thing, right? And we know that we have this to match against, and we hit some question marks. We can make a group of 1 by either of them being the thing. Like, do I need to find groups of question marks and operate on them as groups? That might be better, because then these long things of question marks I can maybe make a little better. Okay, let's try something about that. This is still taking too long. Okay, so let's just make a commit here. So this is part 2 brute force, which I think would work, but isn't actually gonna work. Okay. So for part 2, we're gonna need a different answer, but it is still gonna be row by row. So let's still make a thing on row. Let's make a function, count possible 2 or something. We're just gonna do this differently. And actually I don't really think I want it to live on here. Let's have it be a free floating function like before. Function count possible try 2. And I think it takes in the same thing. It takes in cells array, and it takes in the groups array. Okay, so then let's say I think we're gonna do it differently where we're gonna um we're gonna try to build up. No, because we can't treat groups all as the same. Like this group needs to be broken down into broken, working, broken. Yeah. I'm really not finding a better idea conceptually than brute force here, which is unfortunate. Because it feels like there's got to be a better way to do it. Because I let that run for 12 minutes. And if it didn't finish in 12 minutes, it wasn't going to finish very quickly at all. And there's a possibility I have a optimization that I'm missing, but I didn't see it yet. Current set doesn't equal 0. We push one of those, set that to 0. There's nothing exciting here. If the lengths match, those both know their sizes, I think, so those should be optimized. Yeah. We iterate over them. If none of them are equal, we return right away. If they have the same lengths at the end, we do that. Yep. We get some sets out of it. We check if it's a prefix match. So I could like eventually try to profile this and see what's slow about it. But it's just doing lots of stuff. So I think like I know what's slow, right? Count possibles called a lot. Prefix matches called a lot. So what can I do to speed it up? Um, if the we could have it stop a little earlier, right? Like even if there's unknown indexes. Well, if there are unknown indexes and we're also doing lots of copying, but these copies should be easy. But what I was thinking is if even if there's still an unknown index, we don't have to actually count everything if the prefix match tells us it's full. If the prefix match tells us it's already full, then all of the other question marks have to be working. So it's just one. So if prefix match is full, we return 1. Because they all, no matter what, they all have to be that way. Yeah, I think that makes sense to me. I can get behind that. It might not have even made it faster to calculate that number though, so that's worrisome. Yeah, so I don't think that was a big optimization. I think it was an optimization, but it wasn't really a big one. But maybe I can cut down on the amount of data, right? So it's the same idea, but like once we've done this here, what if these prefix matches came with the count? This was just cell sets.length. I already have, so I don't need to pass that down. I know cell sets.length then. That's just easier. Because what I can do is say, because we have an unknown index. So can I do let cells equal cells at unknown index to the end? I don't need the 2vec there, I don't think. A reference to that, that's fine. And then let broken sets is, yeah, from however many ones we've already matched. So now the arrays get smaller and smaller as we go on, so we don't have to deal with the huge arrays each time. I like that. We blew up, but I liked the idea a lot. Let's see where we blow up though. Unknown index. Oh yeah, because yeah, that makes sense. So those are going to be 0 probably. Unknown index, yeah, so that's the first one, yeah. So now it's just from the beginning of these. Part 1 answer is not that. So I don't think this worked out quite right. That also is not actually faster, but that's fair because it's not doing the right thing. So unknown index, once we've found, I'm not sure about this one. I don't think that's going to change this answer, but oh, it did change that answer. Interesting. That's still wrong though. And it's not a factor of 2 off. It's close though. But it's not. Okay. So if there are unknowns left and we have done a prefix match, then oh yeah, we can't quit out of here because we might be in the middle of a set. We could cut it at the end of a set, but we can't cut it in the middle of a set. Okay, so maybe we do need this to have a return value. So like, let set started. Oh wait, no, this isn't in here. Is it in prefix match? No, it's not in prefix match. It's in 2 sets. Yeah. No. I got lost. Sorry. I need to know where the last set started. Yeah, that is actually a little harder, but I think it's probably in here, right? Yep, because instead of current set, yeah, so let mutable current set start at equals 0. Dot iter dot enumerate. Oops. I comma cell. That's actually just make that a reference to a cell, and then it becomes a cell. Okay, so then current set start at equals I. Oh, none. That's where it equals none. Not, yeah, there we go. And then here we do if it's a none, set it to some. Yep, so now we know where we started. And then here we return sets and where we started. So current set start at. We're going to return those in a tuple. an option of a U size. Perfect. So then this here returns a none. Awesome. Okay, so if we've made it part of the way through, there's a current set that starts somewhere. So when we call two sets, cell sets, and then set started at. Yeah, so set started at isn't used, but it is going to be used down here. So it's not unknown index. So let cut index equals if let some, yeah, set start at index or unknown index. Oh yeah, but actually we do need the cut index, man. And then this is actually gonna, then we do need a new unknown index, actually. It's crazy. This is gonna be the cut index though. That's where we're cutting. But where we change it is now gonna be the unknown index because we have a case where it's not 0 anymore. If there was no set started at though, then it's what we just had. Unknown index and 0. But if it is, then we need to do some math here. So set start at, and then it's unknown index minus set start at. Exactly. Ooh, that's the right answer. That was quicker, I think. That felt quicker. But it still could take like a good minute or two probably with how long, but I think that's the right answer for sure. So I think we're doing this right. I think we're now correctly cutting this up and making it smaller as we go, and that's got to be helpful. Yeah, that feels like it'll help a bit, quite a bit. If we're in the middle of a set. Yeah, like there's definitely something about counting the size of the set versus the size of like the next one you're trying to make and figuring out how many possible positions there are. I was really hoping that this was just going to return within a minute or two and I was going to be able to take that as a win there and have it be fast enough. There's some big ones. There's 1,000 lines, and we got a lot of stuff that we're doing for each of them. Yeah. Okay. So these ones now have an interesting property where segments start at the beginning. I'm actually not sure that's that interesting, but it is kind of true. Once we recurse, there is a set at the beginning. Yeah. I definitely think there's something about counting the number and doing some mathy stuff so I don't have to do everything on its own. Yeah. Okay, so let's try that. So this is where the cut index and unknown index. Yeah, so the cut index is where like the set starts, and then this is the next unknown. What's the last unknown? So I want to do let last unknown in group. So that's like for the cut index, no, for unknown index, yep. Yep, through cells.length, find where it doesn't equal unknown, unwrap or the end of them. Yeah, perfect. So last unknown in group. And it's not last unknown though. Last unknown or broken. So find where it doesn't equal known. It really is just where it equals cell working. Last unknown, or so you find the first one that's broken. We were doing the subtract 1 on the outside. Yep. Yep. Okay, so then we know the size of the group. So let group size equals last unknown or broken in group minus cut index plus 1. Yep. Oh no, unwrap or this actually isn't the right thing. I want to unwrap or that. Because if we want to get back to unknown index if it's the same. This is because this would just be unknown index. Yeah. Group size is just that. So I know the group size and then like the next set. So like let next set equals broken sets at 0, right? Because we're cutting them off every time we like have a match. So then the possible number here, let possible equals the group size minus, so this is the excess. And then let possible equals 2 to the excess. But that's like that does count something, but like when do I do that? Because I can't always do that, right? That's if we take the whole group together. Yeah. So like that could be a shortcut for doing some of it, right? If we can take the whole group together, as one set, we can do that. Let count possible after group plus 1 to the end, broken sets to the end. Yep. Oh no, this just count possible. And then this is the part that's after the group. If count possible does not equal 0, then we return count possible times the possible. Yeah, something like that. I'm not sure about the times though. 2 dot power of excess as U32. Uh, cool. Yeah, broken. Oh yeah. That's a thing we can do. So if there's no matching, um, if broken sets is empty, um, if cell set stock contains any working, right? Any working. Oh, I don't want cells. I just want cells. If cells contains any that are, I think this is broken. The broken sets. So if there are no broken sets, then you get that, else return 1. Yep, cool. This can just be in his empty check. This could be up very at the top, right? We don't need to do anything if broken sets is empty. That's a good one. I like that. Okay, so my other optimization here is pretty not right. That's this. The other one's 21. Sample part 1 answer of 21. That's not right. Is it? Oh no, 21. Yep. Then 7,000. 361 or whatever. But this is taking, oh, but that did work. Okay. Interestingly is that there's no way that that's taking longer, because once we have broken sets being empty, we can just reduce it to a simple return. There's no way this takes longer. Okay, we're gonna leave that. And let's look back at this. Treating everything as a group. Okay, those numbers are wrong, so let's look at this again. So the unknown index group size. This actually isn't the group size though, because it's from cut index. It's from when it starts, not when that happens. Aha. Yep. Okay. 19. Okay, we're getting closer though. Now it's 19. The last time this was 19, it was because we were heading it off by 1 hour on some of these. Opus says, I was hoping to put a less powerful GPU on this machine so I could run a Linux host and pass my good GPU to a Windows VM for gaming, but I actually think it's too big for me to fit anything else in the case. Oh no. That's unfortunate. Hey Goth Chicken, for some reason Twitch set my resolution to something resembling Braille even though I was on 1080p. How anti-based. No, that's unfortunate. I'm sorry that happened. Hopefully you could set it right back though. And thanks for stopping by, and thanks for chatting. Always good to have more people, and I hope you got the resolution fixed. That does not sound like it was fun. Coding streams are one of those things that it definitely seems like you need some pretty good resolution to support nicely. Okay, so I'm trying to figure out if this optimization works. So if we take a whole thing as a set, we know where it starts, We know where the unknown index is, the last unknown. So we know where the whole group is. It goes from where we started all the way to the last unknown or broken in group. Just making sure I know. Whoa, yep. Yep, And the next set that we're trying to match is just this one. So then our group size is however many things there are there. And the excess is how many over we are. Yep. So then it's the possibilities are 2 to the power of excess. Yep. So if there's 0 excess, then there's only one option. If there's 1 excess, then there's 2 options. 2 excess, there's 4 options. Yep. And then count possible after the group. So we look at the last unknown or broken in group. We look from there to the next one, right? Yep, to the end. And we look at the next set. And then if that is not 0, so like if it's at least 1, we say for all of those possibilities, we had this many possibilities, so we multiply them together. Yep, I think that makes sense. And if there were no groups here, that means though that we were saying we couldn't treat that whole thing as a group and we were gonna have to split it. And to split it, we're just gonna keep going one by one, basically. Okay, that makes sense to me, but I definitely have an off by 1 error. So let's actually do this. Let's debug hit group optimization. Right now, let's just do that, and then let's go into our main and make it do a lot less. Let's go just to our sample part 1 answer. And it hit this grouped optimization thing quite a few times. Cool. Not sure what that means for us yet, but that's okay. Okay. If count possible after group equals 0. Sorry. What do we want to do here? What do I want to get out of here to get helpful information? I guess like I could definitely just do cells and see what's going on here. Sure, let's get this. Let's just get some variables that I might find helpful. Sure. Those ones for now. Hit the group optimization. Yep. Unknown, broken, 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 unknown, unknown. Oh yeah, that makes sense. Whoa, excess shouldn't be that big, should it? I thought excess was group size minus next set. Yeah, that shouldn't be that big. Group size, U size. So group size is that. If next size is greater than group size. If next size is greater than group size, then I think I just want to return this. Then count possible after group. This thing can't possibly be the next one you're looking for. Well, that gave me an answer quickly, but it's a very wrong answer of 526. So we're getting very far away. So that made it that made it kind of a lot worse. Interesting. Okay. If next set is greater than group size, then this whole group doesn't matter at all. Is that what I'm saying? That is what I'm saying, but that doesn't make sense. if next set is greater than group size. No, yeah, that was a little bit unfair. We don't really know that everything in here works. But I don't also like that I have excesses here that are like absurdly big. It's obviously from hitting this case where next, like that we're overflowing here. So I think I need to handle that and say if next set is greater, or can I just do, yeah, maybe let's just do this. Let's just wrap all of this saying if next set is less than or equal to group size. If it's one that it'll work for. Well, now we get 58, which is not the right answer either. The answer is 21. So let's just take this whole thing. Okay, so we have some cells and we have some broken sets. If broken sets is empty, if there's no more sets that we're trying to find and there's anything that's broken left, then there's 0 things. And if there's not, there's one option where everything's working. Yep. We create our sets, we do the prefix matching. If there's not a prefix match, we either return, if there was a full match, then there's one option. If it wasn't a full match, then there's no options. I don't know, sorry. If it's not a prefix match, then there's 0 options. You're just done automatically. This one's being tricky, and then the next grouping stuff. So, okay, the cut index is supposed to be the set start. So if there is a set start, we do that. And then the unknown index from there. Oh, I think I'm messing up my unknown index. Okay, so unknown index now is relative to the cut index. Let's just relative to cut. Yeah, I didn't realize that's what was happening. Yep. This is unknown index relative to cut. That's what this was supposed to be. I didn't want it to be changing these ones. There we go. Okay, well, we're still not getting the right answer, but that was definitely part of it. Unknown index minus set start at. Yep, because that's going to be the relative to that. And that would be unknown index minus, yep, minus if set starts there. Yep, perfect. For unknown index plus 1, yep, through cells. Yep, we're going through cells because this is before. I could also just cut it and not have to deal with that as much. That might be helpful. Okay, so now we have it cut. So actually, let's do unknown index here is because I've done the cut now. So then unknown index plus 1 till the end. Yep. Group size is cut index is now 0. And last unknown or broken in group is relative to unknown index, which is relative to the cut one. Yep. The next set, yep. So if the next set is less than or equal to group size, yep. As long as the next set isn't greater than, I think that's really what I'd rather say. If it's not greater than. The excess, how many extra you have, group size minus this, to the power of Count possible after group. So cells last broken or unknown in group is actually relative to that. So actually I think that's still right. And then broken sets with one pulled off of it. Yep. Uh this is already cut. This is yeah. Unknown index is already can be simplified. Sure. Okay, I liked it better the other way, but that's fine, Rust. And then if there isn't any afterwards, oh, if it doesn't equal 0, yeah, because if it equals 0, then it doesn't matter. Oh, we actually could do the multiplication anyways, though. That's interesting. Oh, if it equals 0, we're not returning. Oh. I want to return if it, yeah. Yeah, if it equals 0, then that's not possible. Oh, no. But if it equals 0, then then the optimization isn't possible. That just means I have to split the group somewhere. And to figure out about splitting the group somewhere, I think I'm just going with the brute forcing solution at the moment. Or that's definitely what I'm going with at the moment. Hit group optimization. So cells is broken, and then all those unknowns. What's our, that's something that I want to know. What's our next set? And what's our group size? Just give me some more numbers there. Next set is 3. Broken. Oh. Well, that's 0 because those are there's actually 4 there. Well, that's interesting. Group size. Let known size equals this dot filter for them being broken and then count them. Yep. If known size is greater than next set, return 0. Just nope out if that's the case. Yeah, because we shouldn't be able to hit the optimization there. So let's nope out. There we go. So now we have the next set of 2 broken. Oh, that goes with this one. Count possible after group is 5. Excess is 1. Excess through group size is 4. Count possible after group. Oh, okay. But that doesn't make sense. The group is the entire thing here. Last unknown or broken in group 3. 0, 1, 2, 3. Oh, okay, so that's just wrong. Last unknown or broken in group. So you go from unknown index plus 1 till the end. You find one that's working. Oh, what if we start from this one? You go till it's working, and then you unwrap with length. Okay, that at least makes these optimizations make a lot more sense now. This one is broken unknown, group size of 4. Next set of 1, excess of 3. last, yeah, okay. This at least makes more sense. This one hit the optimization. And by hit the optimization, I mean it means that the let's actually just do what's the whole thing called? Broken sets. Come on, there we go. Okay, so that's the last that's the last set here. Yeah, that makes sense. So broken, unknown, 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 excess of 3 there. The next set's 1. Yeah. Group size is 4, so the possibilities there are, yeah, okay. Unknown, 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 next set of 1. It's the only set. Okay. So it's like kind of working, but like it's definitely not working all the way. Unknown, 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 working. Excess 0. Next set, group size 4. Last unknown or broken in group count possible after group 1. Group size, next set. So there's only one possible way that that one works though either. But we can definitely take it as a group. If next set is less than or equal to group size. No, this doesn't work. That's actually making it return 0, so the number's going to get higher. Oh, but not very much higher. But that wasn't true, because if you had lots with unknowns, maybe they were going to be broken up and the set wasn't going to be that big. So yeah, I'm trying to work on groups now. But I think in about 15 minutes, we're going to call it a day. And I'm not sure I'm going to figure it out, but that's okay. We're going to give it a shot. So at the moment here, this is where a group starts. So last unknown or broken in group. What if we only went up to the size of the next set? Is that interesting? What if I don't take it? Yeah, what if I do that? So we cut to here, and then last unknown or broken in group, we actually only go unknown index plus broken, yeah, plus next set. Unwrap or this again. Yeah. Yeah, that's what I want to do. Because then the group can only be as big as the set. Do I need this thing about known size anymore? I don't think I do. So group size is just that. That's fine. This number, it can just be that number. That's the answer to that. That's funny. If next set is less than or equal, okay, so this one has to be the case now. If there's any that are possible after it, then no. See, I don't think this works. I think I'm breaking my optimization, because like you do need to split them sometimes, and I'm having problems figuring out when I need to split them. Oh yeah, I didn't know that was gonna be too big. Uh, Max of cells dot length. Yeah, the end, like, let end position equals this. And then this is end position again. That'll at least get rid of our that error. Length is 6, but index is 6. Is it the same thing? But this doesn't have a unknown index plus next set maxed with the length. But we don't go to that one. That's interesting. Unknown index plus next set where unknown index is this could just go from 0. Oh, that actually, this isn't supposed to go from here. This should go from 0. This one should go from 0. Because it's the beginning of the group. Yeah. Yeah, okay. This whole group logic is getting harder. I don't think I'm actually getting anywhere. I think I'm just going in circles. I had a working implementation before I tried to do the group stuff. And I think I just broke it by trying to do the group stuff. Let's see. Okay, got five more minutes here, but I'm really thinking we're gonna wrap up here. Because the group things are hard, because you might have to split a group. You might not. There might be some possibilities where you did split a group and some possibilities where you didn't split the group. So that's hard. Yeah, that one, that's... Yeah, the group's real hard. So what I'm thinking, I'm just thinking through this puzzle a little differently. Now, there are 3 groups here. There's this group, and this group. This group needs to be a 1, this group needs to be a 1, and this group needs to be a 3. Here there's just one group, though, and it needs to be split into a 1, a 3, a 1, and a 6. So, like, this one's kind of easy because they match up, and we can know what to do. But when they split... then it's hard. And like in this one, right, this one does need to get split. But this one is at the end and it's known, so we can like trim it off, I guess, right? And just care about this and just care about 1, 1. And then it gets a little easier to think through. Yeah. That's a different way to think about it. I kind of like that train of thought, but I'm not sure if I want to try implementing it now. So the idea is you take the input and you try to strip things off from either the beginning or of the end that are already in those sets. Right? So there's a set of 3 at the end here and a set of 3 at the end here, and this 3 is known. So we just strip it off. Yeah, I think that works. And then we're just left with this thing to think about. Yeah, that works. But then how do we get to the splitting? So like we have this. We could just try each split, I guess, right? And then just like try splitting it in half here and then here and then here, split it into two at each different split and then just add them all up. That does sound kind of reasonable, but I'm not positive I'm going to implement that right now. But we can take a row and break it into its groups where you just have like these sets, right? Basically splitting on working ones, known working ones. And then we know these numbers, and like if you have something that matches at the start or the end, you can strip it off, and if they're all known, it counts as one. If they're all optional, I guess it also counts as one, so it doesn't really matter. You also have to if it's all optional, you have to count that too, where they're all working. Yeah, like it doesn't really get easier. Like I think there's a solution there for sure, but it doesn't really seem easier. Do I like anything that I did here? I kind of doubt it. No, I don't think I do. Let's just revert everything there. It was all about the getting into groups and stuff, and I don't think it was going to get us anywhere. I kind of think that what we're going to do is we're just going to let this run with our brute force. We'll let it run like for as long as it needs to, basically, and hopefully we can get an answer. And then hopefully I'll come back to this part 2 eventually and try to come up with a better solution. I think I like what I was thinking about, so maybe let's try to write down what I'm thinking about, and then that's what we're going to do to wrap up. So let's just write we're just going to write this in a comment here. Oh, but let's do it in here. There we go. Part 2. This answer is not optimized, and takes a long time to run. I think I want to change the count possible implementation to work on groups of things instead of individual characters, basically. Get groupings of each cell and compare with the broken sets to look for pre/post fixes. Post fixes that match. By match, we mean a group of equal a group with size that matches the broken set matches. By matches, we mean a group with a size that matches the broken set. I think that's as good as it's gonna get. It's not a very good description, but it's okay. We can then strip those matches out and work on the smaller inner groups. At some point, we may need to break big groups into smaller groups. I think we could just split in half. And sum up all such splits. It's not really in half, it's in two. And sum up all such splits. Basically for a big group, say that yeah. At some point we will need to break up the groups into smaller groups. We can do that by making each unknown a working cell, and forcing that and using that to break the groups to create smaller groups. We can sum the result for making each unknown a working cell. Yeah, that makes sense. That's how we split the groups. We can sum the results. Yep. Yeah, I think this makes sense. We really want to operate on the groups here instead of individual things. I think that'll be faster for part 2. But in the meantime, we're gonna let that run and see if we can get a brute forced answer. And then I think we're gonna pick back up with this part 2 answer another time. So thank you all for tuning in and coming out with me. Sorry we didn't get all the way through this part 2 solution, but I think we're pretty close. So I hope next time we can get through solving it. I think next time I actually do a stream, we're just going to keep going and get to day 13, but I do want to come back to day 12 eventually. So thank you everyone for coming along and hanging out. Just to remind you, in case you forgot, I'm Corey. I go by CoreyJA online, and you can find me at CoreyJA.com and as CoreyJA on GitHub, Twitch, and YouTube. And with that, I am going to get out of here for this evening. Thanks so much, and I will see everyone around the internet. Bye, team.